everyone, welcome to Map My Tutor, where the chemistry becomes simple, scoring, and actually fun. I'm your chemistry guide, Dr. Sugandha, and today we are going to dive into KSET Chemistry PYQs. This is a real game changer for your rank. Remember one thing, if you feel like chemistry is going in a wrong direction, then I am your catalyst over here. Let's start with the questions. Let's start with the first question. In the reaction between hydrogen sulfide and acidified permanganate solution, what will happen? Which part is going to oxidize and which part is going to reduce? For letting know, let's first write the reaction. Hydrogen sulfide H2S reacts with permanganate, that is MnO4 negative, in the acidified solution, means H positive. What will happen? See, the trick is whenever permanganate in the presence of acidic medium, it will always reduce to manganese 2 positive. Okay? And H2S, this sulfur is going into its elemental state. And water will form along with this. So, you can see here sulfur is in the -2 oxidation state, is moving to sulfur in the 0 oxidation state, that is loss of 2 electrons. Loss of electron means oxidation. And manganese in the +7 oxidation state is turning into manganese into +2 oxidation state by gaining of 5 electrons, that is reduction. So where you can see this option? In the C, H2S is oxidized to sulfur and MnO4 negative is reduced to manganese 2 positive. So this is the right answer. So always remember, whenever permanganate in acidic medium, it will always convert into manganese 2 positive ion. Okay? A member of the lanthanide series, which is well known to exhibit +4 oxidation state. See, this is very important question, and usually this type of question comes in all the entrance exams, that where you need to know the electronic configuration of all the lanthanide and actinide series. Okay, so solving this question, we need to know the electronic configuration. Let's start it with europium, erbium, cerium, and samarium. Europium is xenon 4F 7 6S 2. Erbium, it is xenon 4F 12 6S 2. Cerium, it is xenon 4F 1 5D1 and 6S 2. What is for samarium? It is xenon 4F 6 and 6S 2. He is talking about +4 oxidation state. So we need to lose all the from all the elements, we need to remove 4 electrons. What will it become? It will come out xenon 4F5, xenon 4F10. For here it will come to xenon 4F0 and xenon 4F4. Now see, in these, what will be the most stable oxidation state for which element, where it either is half filled, fully filled, or zero filled? And out of these 4 options, cerium has 4F0 and means only xenon will be there, means which is the noble gas configuration. So this will give the most stable +4 oxidation state. So the answer is cerium. In which of the following pairs both the elements do not have N-1 D10 NS2 configuration? What does this mean, N-1 D10 NS2? Like 3D10 4S2 or 4D10 5S2? He is asking which of these elements do not have. This is very important, don't mistake it. Do not have. So let's see from the options like zinc, cadmium. They are both from the same period, so have the same electronic configuration, which is N-1 D10 and NS2. For this it is 3D10 4S2, and for cadmium it is 4D10 5S2. So both the options contain this electronic configuration. So this can't be the answer. Remove it. Next is cadmium and mercury. This is also belonging to the same period, cadmium and mercury. It is 5d10 6s2. So this also can't be the answer. Next is silver and copper. It comes here. It is copper and silver. So this is N-1 D10 NS1. So both of these elements do not contain the configuration N-1 D10 NS2. So this is the right answer. In the last option, like zinc again contains the same configuration, but copper don't. But we want both the options which do not contain this configuration. So C is the right answer. A ligand which has two different donor atoms and either of the two ligates with the central metal atom ion in the complex is called, this is very important, this complex is known as ambidentate ligand. See, here it is in the option C, ambidentate ligand. What is this? Ambidentate ligand is the ligand which contains two donor atoms, such as in the example like you can see in SCN, sulfur and nitrogen, both are donor atoms, but at a time either sulfur can link to the metal atom or nitrogen can link to the metal atom. So such type of ligands are known as ambidentate ligands. Okay. Which of the following statements are true about NaCl4 negative? Options are, we need to select the true one. The complex has tetrahedral geometry. The coordination number of nickel is 2 and oxidation state is +4. The complex is sp3 hybridized. It is a high spin complex. The complex is paramagnetic. To know all these things, first we need to find out the geometry, oxidation state, coordination number, hybridization for nickel chloride with the help of a valence bond theory. Okay. So we will solve this with the help of a valence bond theory, which is a very famous theory in the coordination chemistry. Let's find out. NiCl4 negative. Let's start with the oxidation step. If we consider this nickel as X, for chloride ion, the oxidation state is -1 for one chloride. There is 4 chlorides, so we'll take -4 is equal to -2. X is equal to -2 plus 4 and X is equal to +2. So nickel oxidation state is +2. Okay. And coordination number in this complex is 4. Why? Because 4 chloride ions are linked to the metal atom. So our coordination number is 4. One thing. Next, we need to find out the hybridization. For this, we will see the electronic configuration of nickel +2, that is 3d8. Okay. 3d8. Let's draw it. D contains 5 orbitals. Which 5 orbitals are these? dxy, dxz, dyz, dxk minus y square and dzk. These are the 5d orbitals. 4s. S contains only one orbital. And 4p. P contains 3 orbitals. Which are those? px, py, pz. Okay. Let's fill these 8 electrons in the d orbitals. Like we'll fill it with the help of a different color. Let's consider this yellow color. 1. Boom. It is not visible. Change the color. Let's take white. 1, 2, 3, 4, 5, 6, 7 and 8. We have filled these according to the Hund's rule. What Hund's rule say? That pairing of electron will not take place until all the orbital contains one electron. Okay. So first we have filled all the orbitals by one electron and then we paired it, and so they contains 2 unpaired electrons. Okay. And now the complex is nickel chloride, 4 chlorine. 4 chlorine will come in these chlorine, chlorine, chlorine and chlorine. These 4 orbitals will come here. Okay. So the hybridization over here is sp3. And as it contains 2 unpaired electrons, so it is paramagnetic in nature. Okay. This all we know with the help of a valence bond theory. And sp3 hybridization means which geometry it is? It is a tetrahedral geometry. because 4 ligands are there. With 4 ligands, either it can be tetrahedral or square planar. Only 2 options are there. And here the hybridization came out is sp3. sp3 means tetrahedral. If it comes out dsp2, sp2d, that is square planar. Okay. So now let's see the options. The complex has tetrahedral geometry. Very right. Complex comes out tetrahedral. So this is the right option. Coordination number of nickel is 2 and oxidation state is +4. See, the coordination number is 4. He is saying 2. So this is a wrong. Oxidation state is +4, but oxidation state is +2. So this is a wrong option. Next is the complex is sp3 hybridized. That is also true. So this is right. It is a high spin complex. What do you mean by high spin? See, chloride is a weak field ligand. If it is a weak field ligand, that means the energy between these two splitted d orbitals, this is E and T2, in case of a tetrahedral, the energy between them is very less. This energy is less. If this energy is less, then electron can easily transfer from this ground state to this E to T2. Transition can easily take place and the maximum number of unpaired electron will be there. So that means weak field means high spin. How high spin? Energy between them will be less and more number of unpaired electrons we will get. For this, like it is 8 unpaired electrons. 8 electrons are there in case of nickel. So how will we fill this? 1, 2, 3, 4, 5, 6, 7 and 8. So we get 2 unpaired electrons. Okay. So this is weak field high spin complex. This is right. Next is the complex is paramagnetic. This is true, right? So option A, C, D and E is the right one. So D is the right answer. Which formula and its name combination is incorrect? We need to tell here incorrect. Always see the question very carefully that either they are asking about correct or incorrect. Okay. See, the first thing, we need to tell the IUPAC name of these formulas. For this, we need to start with the ligand first and that too in a alphabetical order. Okay. See, first option here, chlorine and ethylene diamine is given. Okay. So chlorine comes first because of C. So it is given first. We will not consider this di in the alphabetical order. Okay. So dichlorido, bis, ethane 1,2-diamine, cobalt 3-chloride. This is very right for this. Okay. So this is the right answer. So this can't be our answer. So it is wrong. CuNH3,5CO3 chlorine. Here it is given pentamine for this and carbonyl for this. But this is not carbonyl. CO3 is known as carbonato. Okay. So this is wrong. And he is asking about incorrect. So this is our right answer. For your general knowledge, we can see the other options as well. Like in this option, there are ligands like chlorine, nitro and amine. So for this, we start with diamine, then chlorido, nitrito and platinum. So this is right. For this, it is trioxalato, potassium, trioxalato, del chromate and 3. Okay, so these options are right and our answer is B, which is the incorrect due to carbonyl is not there. CO3 is known as carbonato. In the complex ion Fe(C2O4) 3 negative, the coordination number of iron is. What is coordination number? This is very important term, coordination number. What is it? Coordination number are the number of sigma bonds between the ligand and the metal atom. Okay. So in this complex, this ligand is linked to the metal atom. Now we know this oxalato group, oxalate, is bidentate in nature. And for bidentate, we consider two sides are linked with the metal atom. Okay. So there are 3 in number. So coordination number will be 2 into 3, that is 6. So answer will be 6. So D is the right answer. Okay. Match list 1 and list 2 for the following reaction patterns: glucose reagent, product, structural prediction. That when we react these reagents with glucose, how will the product which product we will get and how we will predict those products. Okay. For this, first we need to write the structure of glucose. What is the structure of glucose? It is CHO, H, OH, OH, H, H, OH. 6 carbons are there in glucose. 1, 2, 3, 4, 5 and 6. Okay, so this is the structure of glucose. Now we will see one by one how this reagent react with glucose and what will be the product and how we can predict the structure of glucose with the help of these reagents. Okay, first is acetic anhydride. Acetic anhydride. Acetic anhydride is CH3CO CH3 part. So now in this what will happen, this acetic anhydride, it is like acetic anhydride OC, it's like acetic anhydride will react with these 5 OH groups and convert it into OCOCH3 ester part. Okay, so by reaction acetic anhydride with glucose, all the OH groups in the glucose will convert into ester OCOCH3 group. So where we can see this option, is there any option like that? Yes, acetic anhydride can go with this. Glucose has 5 hydroxyl groups. We can predict by reaction of glucose with acetic anhydride. So A will match with this 3. Is there any option like that? Yes. In part A, option A and C, A with 3. So we can rule out these 2 options, that is B and D will not be there. Only 2 options now we need to search. Next is bromine water. What will happen if we react glucose with bromine water? Anybody know? Yes, it will convert this aldehyde group into acid. Okay, so from this we get to know that there is a aldehyde group is present. So this is bromine water goes with glucose as an aldehyde group. So it is present in the option A, that B for 1. So from here only we get the answer. It is our choice, we need to see other options or not, but we get the answer from here, that the answer is A. For your knowledge, let's see what will happen if glucose reacts with hydroiodic acid, HI. On prolonged heating of glucose with HI will convert into N-hexane. Okay, and here like there is an option, glucose has a straight chain of 6 carbon atom. 1, 2, 3, 4, 5, 6. From here we get to know that when glucose reacts with hydroiodic acid, then it will give N-hexane. That means 6 carbons are present in the glucose unit. Okay, so C with 2, like this. And hydrogen cyanide, but it will do hydrogen cyanide will convert this part into like this, OH and CN. So from there we get to know that in the glucose unit, a carbonyl group is present which will convert into that OH and CN part. So D is for 4. So this, from here we get to understand that by reacting glucose with these reagents, we can understand that in a glucose there is a presence of a carbonyl group, OH, and 6 carbons are there. Okay. The correct sequence of alpha amino acid, hormone, vitamin, carbohydrates respectively is. Means from the option we need to tell that in a order. First should be alpha amino acid, then hormone, then vitamin and the carbohydrates. Let's see first glutamine. Glutamine is a alpha amino acid that we all know, it is right. Insulin is a hormone which absorbs blood sugar from the blood. Aspartic acid is again alpha amino acid, but we need vitamin over here, so this is the wrong option. Arginine is alpha amino acid. Testosterone is a hormone. Glutamic acid is again alpha amino acid, so again B can't be the answer, right? So rule out. Next is C, which is aspartic acid is alpha amino acid, right? Insulin is a hormone, true. Ascorbic acid is a vitamin, right? Vitamin C is known as ascorbic acid. And rhamnose is also a carbohydrate. It is a alpha sugar. So this is the right option. So from here we get the answer. Like we can see in the last case, this thiamine is not alpha amino acid. It is a vitamin. So this is wrong. Vitamin B1 is known as thiamine. Okay. So this can't be the answer. So we get our answer C. These are all the sequence, following the sequence of alpha amino acid, hormone, vitamin and carbohydrates. Which examples of carbohydrates exhibit alpha link in their structures? Now, what is alpha linkage? It is a kind of covalent bonding. Okay, it is a kind of a covalent bonding between the glucose units. For here, it is alpha linkage is present in which structure? Amylose and amylopectin, cellulose and glycogen, glucose and fructose, maltose and lactose. No, it comes in amylose and amylopectin. Okay, A is the right answer. What is this? Amylose and amylopectin. It is a straight, amylose is a straight chain polymer of D-glucose. Okay, of D-glucose. While amylopectin is a branched chain polymer of D-glucose. Okay, in case of this, linkage is like this. Let's say this is a D-glucose and oxygen linkage. This oxygen linkage is known as alpha linkage. Okay, this linkage is known as alpha linkage. Okay, this is the alpha D glucose. As in the straight chain, so this is known as amylose. If this is a branch chain structure, then it is known as a amylopectin. Okay. So this is D-glucose. When the straight chain polymer occurs, then it is amylose. And in case of a branch chain, it is amylopectin. This contains alpha linkage, which is a covalent bonding, type of covalent bonding. In the titration of a potassium permanganate against ferrous ammonium sulfate solution, dilute sulfuric acid is used but not nitric acid to maintain the acidic medium. What is the reason behind this? Let's see the options. Nitric acid does not act as an indicator. Nitric acid itself is an oxidizing agent. This is very right. Nitric acid is itself act as an oxidizing agent just like KMNO4. KMNO4 is also an oxidizing agent. Nitric acid is also an oxidizing agent because nitric acid HNO3. Here in this HNO3, nitrogen has +5 oxidation state. If it is +5 oxidation state, it can get reduced to NO, N2O, okay? NO2, it can get reduced. So, it is a reducing agent, oxidizing agent, sorry. If they are oxidizing agent, then both of them, if are present in the same titration, they will interfere in the titrant and the analyte. And so, we will not get the best results. So, we don't use nitric acid. So, our preferred choice will be sulfuric acid. Likewise, we also don't use HCl in this because HCl also acts as an oxidizing agent. It releases chlorine, which acts as an oxidizer. So, in such reactions, when permanganate and FAS solutions are included, we use H2SO4 as a safer option. Okay. So, keep remember this, that nitric acid is an oxidizing agent. Okay. And we don't use this in such titrations. The group reagent NH4Cl and aqueous ammonia will precipitate which of the following ion? This is known as group reagent NH4Cl and aqueous ammonia, and they will usually precipitate insoluble hydroxides. Okay. Insoluble hydroxides in the basic medium. This is a theoretical question. You should write this in your notebook in a notes that this group reagent precipitate in the insoluble hydroxides in the basic medium for aluminium 3 positive, chromium 3 positive, and iron 3 positive. So let's see which is the option present. Aluminium 3 positive. So this is our right answer. Okay, these are not the options, right? So this is the right answer, aluminium 3 positive. Okay. In the preparation of sodium fusion extract, the purpose of fusing organic compounds with a piece of sodium metal is to, why we fuse organic compound with a sodium extract, sodium metal, to make a sodium fusion extract? So that we can convert the organic compound into an ionic form, which will help us to detect the ions and in a easy manner. Okay, so for our ease, we convert the organic compound into ionic form. So this is the right option, option A, that convert the elements of the compound from covalent form to the ionic form. Okay. The sodium fusion extract is boiled with concentrated nitric acid while testing for halogens. By doing so, what will happen? Either it increases the solubility of AgCl, increases the concentration of nitrate ion, decomposes Na2S and NaCN if formed, or help in precipitation of AgCl. What do you think? You know, this is a very famous test known as Lessing test, LASSAIGNES test, which we do for halogens, which is very famous for the detection of halogen. In this, what will happen? This is the right answer. Decomposes Na2S and NaCnF4. Why? See, what we do, when we detect halogen, we boil this sodium extract with nitric acid. Okay, and when we boil, there is an option that we can get cyanide from nitrogen and sulfur, this sulfur, okay, from this elements. And what will happen? They will interfere in the detection of halogen. So we need to rule out this, because in the test, in this lesson test, we use AgCl. Now AgCl, what will do? AgCl will bind with this sulfur and form Ag2S, and with cyanide AgCN, and white precipitate will form. So it will interfere in the detection of halogen, and we might get confused by using that. So for ruling out, we remove this, decompose Na2S and NaCN if formed by boiling nitric acid with sodium fusion extract. Okay, so reminded that decomposes Na2S and NaCN if formed in the lesson test. Okay, so C is the right answer. Which of the following is not an aromatic compound? Do you know what is aromatic compound? Aromatic compounds are those compounds which follow Huckel rule. What is Huckel rule say? That a compound must contain 4n plus 2 pi electron, where n is 0, 1, 2 means it can be 6 pi electrons, 2 pi electrons, 10 pi or 14 pi electrons. Okay. And along with this, a molecule should be planar in nature. It should be cyclic and conjugated in nature. So these are the 4 points that must be followed by an aromatic compound. That is, it should contain 4n plus 2 pi electrons, planar, cyclic and conjugated in nature. Let's see the options now. In option A, see, 1 pi bond contains 2 electrons. So here 2, 4, 6 pi electrons are there. So it is aromatic, right? It is planar in nature. It is conjugated because it contains this plus bond. Due to this, it is a conjugation. In conjugation, here it is 4 pi electrons. So it is not aromatic. This is our answer, because it is 4 pi electrons, and for being a compound to be aromatic, it should contain 4m plus 2, which is so this is not following the Huckel rule. So it is non-aromatic. Okay, see here what it is. It is anti-aromatic. Okay, because it is planar in nature. For a compound to be non-aromatic, it should be non-planar. Okay, it is planar, so it is anti-aromatic. Let's see here. It is 2, 4, 6, 8, 10, 12, 14. 14 pi electron. It is also following the Huckel rule. So this is aromatic. Okay, here it is 2, 4. This minus also gives 2 electrons. So it is 6 pi electrons. So This is also aromatic in nature. So A, B and D is an aromatic compound, and here he is asking about no, not an aromatic compound. So C is the right answer. The IUPAC name of the given organic compound is, we need to name this compound by IUPAC, what it can be from C. And both the terminals there is, one is double bond and here it is triple bond. Now from there we will start the numbering. Tell me. See, the trick is whenever we have double bond and triple bond on the end side, we always start numbering from the double end, double bond. Okay? So we will start from here 1, 2, 3, 4, 5 and 6. Okay? So for 6 we use hexa. So it will be hexa. And double bond is on a position 1 and 3. So it will be hexa 1,3 diene. Okay? And triple bond is on 5th position. So it will be 5-ine. Of this diene, we will not write this E because it is start from Y. Okay? So the answer is hexa 1,3-diene 5-ine. This is the right answer. So please remember, whenever there is a double bond and triple bond on the terminal position, we always start numbering from the double bond side. Okay? Among the following, identify the compound that is not an isomer of hexane. See the number of carbon in this 1, 2, 3, 4, 5, 6. So it is right. It is a isomer of hexane. So this can't be the answer. See the next. It is also 1, 2, 3, 4, 5, 6. But here the molecular formula of this structure is C6H12. And we know for hexane the molecular formula is C6H14. So this can't be the isomer of hexane. Okay. Here you can see from the other option as well. This is an isomer of hexane. This is also 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We can write hexane in this way. So this is the right answer. This is not an isomer of hexane. Okay. Because the molecular formula is different. Fine. Let's move to the next question. The organic compound, this can be classified as benzyl halide, aryl halide, alkyl halide or alidic halide. Let's see, if we remove chlorine from this, we will get this position. This is CH, CH3 and CH3. And this position is known as benzylic position. This is known as benzylic. So this is known as benzylic. This is benzylic halide. So A is the right answer, benzylic halide, because this position is known as benzylic position. Okay, benzene with CH2 is known as benzylic position. Okay, so this is benzyl halide. Chlorobenzene reacts with bromine gas in the presence of anhydrous AlBr3 aluminum bromide to yield para-bromochlorobenzene. This reaction is classified as, either this reaction is nucleophilic substitution reaction, electrophilic substitution reaction, addition reaction or elimination reaction. Let's find out. Chlorobenzene. This is chlorobenzene. When it reacts with bromine gas, what will happen? It will give para-bromochlorobenzene. Para-bromochlorobenzene. Okay. So see, what will you say? See here, this bromine will react with aluminium bromide and forms Br positive and AlBr4 negative. Okay. So this Br positive will act as a electrophile and attack at the para position. This chlorine is electron withdrawing in nature and affects, here comes minus M effect, and chlorine is ortho and para directing. So here bromine comes at the para position preferably. Okay, so this is para bromochlorobenzene and this bromine is acting as a electrophile. So this reaction is electrophilic substitution reaction because we are substitute bromo that is acting as an electrophile at the para position. So this is electrophilic substitution reaction. Okay, so B is the right answer. The organometallic compound, this on reaction with D2O, what will happen? See, this is CH3, 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 MgBr. I hope you must know that RMgX, this compound is known as Grignard reagent. And this is a type of Grignard reagent only, right? This is R, this is Mg, and this is X. So this is Grignard reagent. And when we react with D2O, what will happen? See, this Mg is positive and this carbon is negative. So from here, D, OD, D is positive, OD is negative. So this D will attack here at the carbon where this carbon is acting as a nucleophilic position. So the answer will be C, CH3, this CH3, CH3 and D plus Mg, Br and OD. So this is our answer. Where it is? C at the third position. C option CH33CD. So this is the right answer. Okay. The major product formed when 1-bromo-3-chloro-cyclobutane reacts with metallic sodium in a dry ether. What will happen? 1-bromo-3-chloro-cyclobutane. This is a cyclobutane. 1-bromo and 3-chloro. 1, 2, 3 and 4. So this is the third position. Chlorine over here. This is our reactant. He is saying what will happen when we react this with metallic sodium in a dry ether. Sodium in a dry ether. This is a very famous name reaction. We use sodium in a dry ether in which reaction? Which name reaction is this? This is Wurtz reaction. Wurtz reaction. Wurtz reaction is when we react 2Rx, it will give in a sodium dry ether, it will give this RR. Alkene will form. So similar will happen in this reaction. These two, chlorine and bromine, will remove and the product comes out to be this. This is known as intramolecular Wurtz reaction. So this B option is similar to this, right? This is the right answer. Okay. So this reaction is known as intramolecular Wurtz reaction. These reactions are very important. Ethyl alcohol is heated with concentrated sulfuric acid at 413 Kelvin. The major product formed is ethyl alcohol. What is the formula for this? CH3CH2OH. Write it 2 times, CH3CH2OH. And when we heat it with concentrated sulfuric acid at 413 Kelvin, water molecule will remove on heating. Okay, minus water. So we will get the ether CH3, CH2O, CH2 and CH3. So this is our answer. Let's see. This C2H5O, C2H5. Okay, this is our answer. So on heating ethyl alcohol or any alcohol at a high temperature in the presence of a concentrated sulfuric acid, we will get ether. Okay. Phenol can be distinguished from propanol by using which reagent? This is very famous. This is with the help of a bromine water. Bromine water. What bromine water will do? This bromine water is used for the test for unsaturation. Unsaturation compounds or the special compounds such as phenol is also. Okay. Unsaturation means double bond or triple bond containing compounds. Okay. So in this phenol, structure of phenol is this, right? Fit benzene ring and OH. And propanol, it is linear CH3, CH2, CH2OH. So this is saturated compound and this contains unsaturation. So with the help of a bromine water, we can distinguish a saturated and an unsaturated compound very easily. So phenol can be distinguished by bromine water and gives a white precipitate. And brown color of bromine will then disappear. Okay. So bromine water helps in distinguishing phenol and propanol. Okay. So this D is the right answer. Let's start with the 24th question, that is match the following with their pKa values. See, in the question we have given 4 acid and their pK values. Now we know that acidic strength is inversely proportional to pH and pK. Higher the acidity of a compound, smaller will be their pH and pK values. Okay. First, let's see the structure of these compounds. It is given phenol, paranitrophenol, ethyl alcohol, CH3, CH2OH, and picric acid. You know, picric acid is very explosive when it is present in a dry form. And this is the structure of picric acid. It has a foul smell and very acidic in nature. Picric acid is the most acidic in nature out of these four. How? See, NO2 is a strong electron withdrawing group and 3 NO2 groups are present here and they will pull the electron from this bond, from this OH. Okay, they will pull the electrons and this H positive can be released very easily, and that's why this picric acid is the most acidic. Next, in this compound also one NO2 group is present, so it will also pull the electrons. So in priority, this is the most acidic. Then this, and then out of phenol and propanol, this phenol is more acidic as compared to this ethanol. Okay, so this is the priority order. Due to the presence of electron withdrawing group, it is the most acidic. Okay, and see, if this is the most acidic picric acid, its pK value will be the least one. So picric acid match with B, whose value is 0.78. Is there any option with 4 with B? All this A and D options are there. So we can remove this B and C, right? Next is paranitrophenol. Paranitrophenol will go with this D. So this is again in both the options. Next is, third is phenol. Phenol will be 10. So 1 with C, 1 with C. So D is the right answer. And ethyl alcohol has the highest pK value, that is 16. So quote with B. So D is the right answer. So please remember that picric acid is one of the most strongest acid because of the 3 nitro groups present in it. Okay. And acidic strength is inversely proportional to their pK values. See, in this question, a reaction is given in which this group reacts with HI. What will be the A and B will form? CH3, CH3 and OCH3. Here, either it can be this I reacts with this part or form this. See how it will happen. If we break this bond, carbocation comes here. This will form a carbocation and this will come like this. Because oxygen is more electronegative, negative charge comes on oxygen, and here positive charge comes on carbon. So it will break from here. See, and this carbocation, in carbocation, tertiary carbocation is the most stable. So this is a tertiary carbocation. Tertiary, then secondary, then primary for the stability, right? And so this tertiary carbocation is most stable. So in this case, it will happen like this. C, CH3, 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 and then I will come here and it comes like CH3OH. Because this H is positive, I is negative, this negative parts comes and attack on this carbocation and form this molecule, this 3 tertiary group, and then with the iodine and CH3OH alcohol. Let's see where the option matches. So see, in the first option, it is CH3I and this OH. So it is not a right answer. I and CH2OH. So this is the right answer. Okay. Because we know that this tertiary carbocation is the most stable out of these, and bond will break from here. Oxygen will carry a negative charge and carbon will carry a positive charge. Okay. Next is oxidation of toluene with chromyl chloride followed by hydrolysis gives benzaldehyde. This is a very famous reaction. Very famous reaction of chapter aldehyde, ketone and carboxylic acid. It mostly comes in all the exams. So you must know this reaction. This reaction is known as Itard reaction. Let's see what with this reaction says, that when toluene, this is a toluene, reacts with chromyl chloride CrO2Cl2 in the presence of this methane, dimethane, CH2, what it will form? It is CHOCrOHCN2. This intermediate will form and then convert it into benzaldehyde. Okay, benzaldehyde. This is known as Itard reaction and a very famous reaction. Okay. Statement 1. Here we need to tell which is the right statement. Out of these two or both are correct. Statement 1 says, reduction of ester by di-BLH followed by hydrolysis give aldehyde. Yes, this is true. This di-BLH is a reducing agent. And this reducing agent do reduction of ester into aldehyde under controlled condition. Okay, under minus 78 degrees Celsius under controlled condition, it converts ester into aldehyde. So this is a right statement. Statement 2 says, oxidation of benzyl alcohol with aqueous KMnO4 lead to the formation of benzaldehyde. No, this is not right. When we react benzyl alcohol with permanganate, potassium permanganate, it will give benzoic acid, not benzaldehyde. So the statement 1 is right, but statement 2 is false. So statement 1 is true, but statement 2 is false. So A is the right answer. Okay. Arrange the following compounds in their decreasing order of reactivity towards nucleophilic addition reaction. We need to arrange these 3 compounds according to the nucleophilic addition reaction. See, CH3 CH double bond O. Nucleophile attacks better when we have an electron deficient compound. Okay. More the compound is electron deficient, more is the reactivity of a nucleophile on it. So in this case, we have 3 options: CH3, C double bond O CH3 and CH3, C double bond O C2H5. These are the options. We have to arrange these. See, in this case, there is only one donor. CH3 is a electron donating group. Here, 2 electron donating groups are there. And here also 2 electron donating groups are there. So, out of these 3, here only 1 electron donating group. So, the deficiency. So, out of these 3, this carbocation is electron deficient. So, nucleophile will attack here first. Okay. So, in decreasing order, first will come this CH3CHO. And while in this, 2 electron donating groups are present. So, the electron deficiency of this compound is decreased because 2 groups are already donating this carbon. So, it will be electron rich. Why nucleophile will attack on a carbon which is already electron rich? It is not electron deficient anymore. So, its order of reactivity is lesser as compared to the aldehyde. And here, 2 electron donating groups are present. Apart from that, this C2H5 will do steric hindrance. Okay. So, when we arrange this CH3CHO will come first. Then second is acetone and the third is CH3C double bond O C2H5 will come. I hope you understood that as many number of electron donating groups are present, nucleophile will attack slow. Because nucleophile is electron rich and it tries to attack on that carbon which is electron deficient. So out of these three, this acetaldehyde is the most electron deficient carbon. In this carbonyl is most electron deficient. So nucleophile will attack here. Which of the following has most acidic hydrogen? In all these options, we have to find out the most acidic hydrogen. Okay. So when dichloroacetic acid, this is dichloroacetic acid, 2 electron withdrawing groups are present. Okay, let's compare by drawing all the structures. Trichloroacetic acid, here 3 electron withdrawing groups are present. Chloroacetic acid and propanoic acid. See, here low electron withdrawing group is present. Here 1, here 2 and here 3 electron withdrawing groups are present. So when more the number of electron withdrawing groups are present, this H can easily be removed. So it is the most acidic hydrogen because it can easily remove due to the presence of the electron withdrawing groups. So out of these three, trichloroacetic acid gives the most acidic hydrogen. 30th question. Which of the following reagents are suitable to differentiate aniline N and methyl aniline chemical? This is very famous test known as carbalamine test, where we can differentiate aniline, that is primary amine, and N-methyl aniline, that is a secondary amine. Okay. This carbalamine test, with the help of a carbalamine test, we can differentiate, which includes reagent chloroform and alcoholic potassium KOH. What this do? Chloroform and alcoholic KOH. This is chloroform and alcoholic KOH when reacts with primary amine, it will give isocyanide group, which has a foul smell. So it clearly differentiates the primary amine with secondary or tertiary amine. Secondary or tertiary amine will not give this test. Only primary amine will give the carbalamine test. So in this way, we can differentiate primary amine with a secondary amine, that is aniline and methyl aniline, with the help of a carbalamine test, that is chloroform and alcoholic potassium KOH. Which of the following reactions does not yield an amine? Let's see. Rx plus NH3 ammonia. What will we get? It will be R, NH2 and HX. So we are getting amine, so this can't be our answer. Next is RC111N with hydrogen and nickel. Hydrogen and nickel is the reducing agent. So we'll get RCH2, NH2 in this case. So this can't be an answer as well. Third option is nitrile with water. See, this is a very important reaction. Whenever there is a nitrile, ester, all these on hydrolysis give acid. Okay, so we will not get amine. So this is the right answer. On hydrolysis of nitrile, we will get acid. Okay, here also LiLH4, this is a very strong reducing agent, and in this case, we will get RCH2NH2. So apart from this third option, in all the cases, we are getting amine. So third is the right answer. Okay. So let's see, where is this? Only 3. So B is the right answer. Match the compounds given in list 1 with the items given in list 2. Benzene sulfonyl chloride. What is the structure of benzene sulfonyl chloride? It is SO2Cl. So this is known as Hinsberg reagent. This is very important reagent. You must know this name. This is known as Hinsberg reagent. Okay. Next is sulfonilic acid. That is SO3H and NH2. So this is a zwitterite. Whenever if a molecule, there is a dipole, that is a positive and negative part, both are present, that is SO3 negative, NH2 positive, both are present, such type of molecules are known as zwitterite. Okay. So sulfanidic acid is a zwitterite. Next is alkyl diazonium salt. What is alkyl diazonium salt? Let's see this. So N, triple bond N, this is diazonium. This we represent for a diazonium, okay, N triple bond N. When this is a good leaving group, we will get this thing. So carbocation, this carbocation is not that stable, or this is a stable, but it will react with water and tend to form this OH. Okay, so dialkyl diazonium salt will give conversion to alcohols on reacting with water. Okay, so alkyl diazonium salt, in this case, this is very good leaving group. N2 is a good leaving group and we will form alcohol. Next is aryl diazonium salt. This is the only option left and it is used in the preparation of dyes. So for 1 we will go for B. Here it is 1 for B, 2 for A and 3 is for D and 4th is for C. So this is the right answer. C is the right answer. Okay. The number of orbitals associated with n shell of an atom. See, this n shell. There are shells, I hope you remember, that is K, L, M, N. These are the shells. So he is asking the number of orbitals in this n shell. So for this, n value is 1, 2, 3 and 4. For calculating the number of orbitals, formula is n square. That means 4 square. So the answer is 16. So in the nth shell, there are 16 orbitals are present in the, okay, so in an atom. So see, which 16 orbitals are these? N shell means it has S, P, D and F orbitals. Okay. For S there is 1, for P there are 3 orbitals, for D there are 5 orbitals and for F there are 7 orbitals. Its total is 60. Okay. According to the Heisenberg uncertainty principle, the value of delta V delta X for an object whose mass is 10 raised to power minus 6 kilogram, we need to calculate the value of delta V and delta X. So first tell me what is Heisenberg uncertainty principle says. What is it? According to Heisenberg uncertainty principle, we can't calculate the value of a position and momentum both with accuracy at the same time. Okay. Okay, for this, the formula is delta V delta X is equal to H by 4 pi m. This is very, very famous and important formula. You must know this formula. So this is velocity and this is position. Okay, this is mass and this H is a Planck's constant. We know the value of H, that is 6.626 into 10 raised to power minus 34 joule second by 4. Value of pi is 3.14 and the mass given is 10 raised to power minus 6 kilogram. Now, as this mass is in kilogram, we need to convert this units. 1 joule is equal to 1 kilograms meter square per second square. So we will convert this and we will write kilogram meter square per second square, and then this second will cut with it and it will give minus 1 and this kilogram will cancel out and we will get the answer, this 5.2 into 10 raised to power minus 29 meter square per second. Okay, so on calculation you will get the answer C. Given below are the two statements. We need to tell which statement is right. Statement 1. Adiabatic work done is positive when work is done on the system and internal energy of the system increases. Is this statement right or wrong? Yes, this is right. Because whenever work is done on the system, it is always positive. Okay. Remember, work is done on the system. This is positive. And work is done by the system is negative. Okay. So he is talking about work is done on the system. So it is positive, it is right. and also asking that internal energy of the system increases. Yes, that is true. If work is increases, internal energy will definitely increase. The formula for internal energy is delta E is equal to Q plus W. So if this work is increasing, so internal energy will also increase automatically. So this statement is the right statement. See the next statement. No work is done during free expansion of an ideal gas. This is also very, very true. This is directly from the NCRT. You know, these statements are directly given over there that no work is done during free expansion. Whenever there is a free expansion of a gas, that means no work is doing over it. So no work is done, and this is the right statement as well. So both the statements are true. So our answer is C. Both statements 1 and 2 are true. Okay. Which one of the following reactions has delta H is equal to delta U? See, direct questions are coming from equilibrium and thermodynamics. These are the very important chapters for the case set. Okay. So please focus on these chapters. This is a direct reaction. Delta H is equal to delta U plus delta Ng RT. See, he is asking when these two terms will be equal. These two terms will equal if these are constant, delta Ng is 0. Then these two terms will become equal. What is this delta Ng? Delta Ng is number of moles of gases in the product side minus number of moles of gases in the reactant side. So you can calculate the delta Ng value in all these cases. Wherever it becomes 0, delta H is equal to delta U. See here. In this case, we only talk about gases. Remember this. So here the gases are 6 moles. Here it is 15 by 2. So they are not equal. So this can't be the answer. See in this case 1 plus 1. 2 moles of gases. Here also 2 moles of gases. So 2 minus 2, it will be 0. So delta Ng is 0. So this term will be equal. So B is our right answer. Okay. You can see from in the C and D option, here the number of moles are 2, here the number of moles are 4, again not same. Here 1 and here no, with 1 minus 0, again it will be 1. So delta H is not equal to delta U in this case. So B is the right answer. Identify the incorrect statements among the following. All enthalpies of fusion are positive. This is very right. For endothermic, all enthalpies, fusion is positive. Yes, these fusion terms are endothermic in nature, so the terms will be positive. The magnitude of the enthalpy change does not depend on the strength of the intermolecular interactions in the substance undergoing phase transformation. This is wrong. It do depend on the strength of the intermolecular interaction. So this is the incorrect statement. C is when a chemical reaction is reversed, the value of delta RH naught is reversed in sign. This is also right. Yes. If we reverse the reaction, sign will also get reversed. So these two options are right. Next, D is the change in enthalpy is dependent on path between initial state and final state. This is again wrong. Path functions are only work and heat. Apart from that, all are state functions. So this change in enthalpy is a state function, not a path function. So this term is also wrong. For most of the ionic compound, delta solution H naught is negative. This is again wrong. It is positive. It is positive. So it is not negative. So only A and C is right. So C is the right answer. Which of the following statements are true about equilibrium? See, let's read the statements. Equilibrium is possible only in a closed system at a given temperature. See, these terms are again from the NCRT. Direct lines are coming from the NCRT. If you read NCRT very carefully, especially for inorganic and physical chemistry, you will attain very good marks in KCET. So please focus on NCRT. This is very predictable paper, means highly predictable paper. You can just go through orally through NCRT and you will get good marks. Okay. See, this is the right equation that equilibrium is focused only on a closed system. at a given temperature. Next is all the measurable properties of the system remain constant at equilibrium. This is also true. At equilibrium, all the measurable properties are constant, right? An equilibrium constant for the reverse reaction is the inverse of the equilibrium constant for the reaction in the forward direction. This is again right, that equilibrium constant for the forward and backward reactions are in the inverse term. So this is again right. So all the terms are right. So B is the right answer, that A, B and C all are right. Now this is again from the equilibrium chapter. See how many questions are coming from thermodynamics and equilibrium. This is the most important chapter. According to the Le-Chatelier's principle in the reaction, in this reaction we need to see the formation of methane will be favored when, in which case. See, here we are talking about the concentration terms, right? Concentration. So how will we relate concentration according to Le-Chatelier's? It says that wherever the concentration is low, is less, at that point, the equilibrium will be shift. Okay. So in this case, see, we need to do the formation of methane. So we want this thing, formation of methane. How will it be formed? If the concentration of carbonyl, this carbon monoxide is high. If the concentration of carbon monoxide is high, means reactant side is high, then the product side concentration will be less. If it is less, equilibrium will shift towards this side, right? So, increasing the concentration of carbon monoxide is the right answer, first thing. Next is increasing the concentration of water. If we increase the concentration of water to this side, then this side concentration will be less. So, equilibrium will shift backwards. So, this can't be the right answer. We want equilibrium towards forward direction. Then only we can get the formation of methane. So, we will choose only those options in which the equilibrium will shift in the forward direction. Okay. So, B is wrong. Decreasing the concentration of CH4. Yes, if we decrease this concentration, then equilibrium will shift towards the forward direction, because it will shift towards that direction where the concentration is low. Okay. So, C is also the right option. Decreasing the concentration of H2. Again, if we decrease this side, equilibrium will shift towards backward. So, D is also wrong. So, only A and C is the right answer. So, where it is? Yeah, D. D is the right option. Okay. I hope you are understanding this. This is a very important question. One question will definitely come from the Le-Chatelier's principle. Please do it carefully. See again equilibrium. The equilibrium constant at 298 Kelvin for the reaction, this is 100. If the initial concentrations of all the four species are 1 molar each, then equilibrium concentration of D will be, we need to calculate the equilibrium concentration of D. Let's solve it. A plus B gives C plus D. Okay. Initial concentration is 1 molar for all. After time t, it will be 1 minus x because this is the other reacting side. So, they will react and they will disappear and the formation, product of formation will take place. So, it will be 1 plus x. So, for equilibrium, but we will write product over reactant. So, it is 1 plus x by 1 minus x, 1 minus x. The value given for equilibrium is 100. So, it is 100, 1 plus x whole square by 1 minus x whole square. So, it comes out to be 10 is equal to 1 plus x, 1 minus x on square root. Okay. So, 1 plus x is equal to 10 minus 10x, right? On rearranging these terms. So, it will be 9x. We will give this 1 to this. So, it is 9 is equal to this 11x. So, x will be 11 by 9. Okay. When we put the value of this, it comes out to be 0.818. And the question is asking about the concentration of D. For D, it is 1 plus x. So, the concentration of D is 1 plus x. Then here x is 1 plus 0.818. So, it comes out to be 1.818 is the right answer. Is it there? Yes, this. A option, 1.818. So this is the right answer. Okay? I hope you are understanding these things. This is very normal calculation. You can do it very easy. Variation of solubility with temperature T for a gas in a liquid is shown by the following graph. What will happen when we increase the temperature? Solubility of the gas will generally decrease. Okay, because when we heat now, what will happen? Kinetic energy of the gaseous molecule will increase and they will try to escape out from the solution. So the solubility will decrease. Is there any graph where we can see the decrease in solubility? Yes, option B. As the temperature is increasing, solubility of a gas is decreasing. Okay, so B is the right answer. 180 gram of glucose is dissolved in a 1 kilogram of water in a vessel. The temperature at which water boils at 1.013 bar is, we need to calculate the temperature. And here the boiling point is also provided. And the Kb value is given. From the formula, as the value of Kb and boiling point is given, you can guess what the formula is. We need to calculate the temperature. Here the formula will comes delta Tb is equal to I kbm. This is for the elevation in boiling point in the colligative properties. I hope you remember. Yes? So this formula we will use for solving this question, where I is the Van't Hoff factor. And for glucose, the value of I is 1. Because it is a known electrolyte. It will not dissociate into ions on dissolving in a solution. So the value of I is 1 for glucose. Kb value is provided. M is molality. What is molality? Molality is the number of moles of solute dissolved in 1 kilogram of a solvent. So here what will be the value of molality? M is number of moles of solute. How will you calculate the number of moles of solute? For N, it is 180 weight over molecular weight. See, 180 gram of glucose is given. So this is weight. For number of moles, how we calculate? Weight over molecular weight. So weight is 180 gram. Its molecular weight is also 180 for glucose. Okay. So, and it is present in 1 kilogram of solvent. 1 kilogram of solvent. So, molality will be 1. Okay. Now, let's put all this in this equation. Delta Tb, it will be Tb minus 373.15, that is for the pure solution, is equal to 1 into Kb value is 0.52 multiply by value of M is again 1. So, Tb is 0.52 plus 373.15. So, the answer comes out to be 373.67 Kelvin. So, this is our right answer, that is option D. Okay. So, please read all the 4 colligative properties. It is very important. One question will definitely come from this point. If nitrogen gas is bubbled through water at 293 Kelvin, how many moles of nitrogen gas would dissolve in 1 liter of water? Assume that nitrogen exerts a partial pressure of 0.987 bar. This is Kh is known as Henry constant. Value of Henry constant is given in the exam. So, what do you mean by Henry law? What is it? Henry law states that when we put pressure on a gas, the solubility of the gas increases. Okay, as much as the pressure is increased, solubility of a gas in solution will increase. Okay, so that this Kh is the Henry constant. And here we need to calculate the number of moles of a nitrogen gas. How we will calculate the number of moles of nitrogen gas which is dissolved in a water? See, we will apply Henry law. According to Henry law, V is for pressure, Kh is Henry constant and X is the mole fraction. This mole fraction is for the nitrogen gas. We need to calculate the mole fraction first. Because mole fraction, from mole fraction, we can calculate the number of moles, right? Xn2, this is mole fraction. This is the number of moles of nitrogen and number of moles of nitrogen plus number of moles of water. If we calculate these two terms, we can calculate the number of moles of nitrogen. Very simple. See, pressure over kH. Now, what is the value of pressure here? It is 0.987. 0.987 bar. Value of kH, that is 76.48 kbar. So it comes out to be 1.29 into 10 raised to power minus 5. And remember, here this will be converted to 10 raised to power minus 3 and bar will get cancelled, and this mole fraction is always unitless. Okay. X N2 comes out to be this term. Okay. Now we will put this value here. As the solution is very dilute, we will consider it as n number of nitrogen by n number, means number of moles of water. Now how will you calculate the number of moles of water? Here it is 1 liter of water. The amount of water is 1 liter, so it is 1000 over what is the molecular weight of water? It is 18. Okay, so answer will be 55.5 moles. So we just need to put the values of number of moles of water over here and mole fraction of nitrogen over here, and we will get the number of moles of nitrogen which has been asked in the question. Okay, let's see. 1.29 into 10 raised to power minus 5 is equal to number of moles of nitrogen by number of moles of water, that is 55.5 moles. Okay, so when we multiply these two terms, we get the value of n nitrogen, that is equal to 7.16 into 10 raised to power minus 4. Okay, so this is our right answer. Okay, please do calculation at home. The correct statements about galvanic cell. For galvanic cell, there is a small trick. Remember this thing. L-O-A-N. L is left, that is left side. O is oxidation. A is anode. And N is negative. You can remember this term, that L-O-A-N, lone. If you remember lone, whenever galvanic cell comes, now remember lone. What is lone? Means on the left side of a cell, this is left side, and this left side, this is anode. Here oxidation will happen. This is cathode. It is negative. This is positive. Okay. These terms you must know. Okay. Now solve the question. Current flows from cathode to anode. Yes, current will flow from cathode to anode. This is very right. Current will flow from cathode to anode. And anode is a positive terminal. No, C, anode is a negative terminal. So B is wrong. E cell is less than 0, then it is spontaneous reaction. No, no, no. For a spontaneous reaction, delta G is less than 0, means negative. And delta E is greater than 0, that is positive. So this is a wrong option. E cell is greater than 0, not less than 0. Okay. And cathode is a positive terminal. This is right. Cathode is a positive terminal. So A and D is the right option. Is there anything? Yeah. B option. A and D only. Okay. The electronic conductance depends on, let's see the options, the number of valence electron per atom, concentration of the electrolyte, size of the ions, or the nature of the electrolyte added. See, conductance. Conductance means to conduct electricity. When will it happen? When the electrons flow will be there. So, it depends upon the number of valence electrons per atom. Okay, it depends upon the valence electrons. Okay, more the number of valence electrons will be there, more will be the value of the conductance. Okay. For a given half cell, aluminium 3 positive plus 3 electron aluminium, on increasing the concentration of aluminium ion, the electrode potential will, what will happen? Let's see. This is an important question of electrochemistry. Okay. And the very important reaction that is known as Nernst equation. E is equal to E naught, that is E cell, is equal to E naught cell minus 0.0591 by N log Al aluminium solid by aluminium ion, 3 positive ions. Okay, we will write this equation like this, Nernst equation. Okay, this is known as Nernst equation, very important. So, for solid value will be 1, and for we need to see for the value for the aluminium ion, that what will happen in this value will increase. So, see, we will write E cell plus 0.0591 by number of value of N is number of electrons are 3. So, it will be 3 log Al 3 positive. So, on increasing the concentration of aluminium 3 positive, the value of the E cell will increase. Okay. So, answer is C, increase. Let's move to the next question. Match the following and select the correct options for the quantity of electricity in Coulomb per mole required to deposit various metals at the cathode. We need to tell how much this quantity of electricity will come for all these metal ions. So, C, for silver positive, it will absorb 1 electron, will get silver. Magnesium 2 positive will absorb 2 electron and will give magnesium. Likewise, aluminium 3 positive, 3 electrons, aluminium. And titanium 4 positive plus 4 electron will give titate. Now, for 1 Faraday, for 1 electron, for 1 Faraday, it will give 965,400 Coulomb. So, we just multiply for silver 1 into 96500 and we will get the same 96500. Is this in the answer? Yes. For silver, it will be the 3. From the options, we will get that only one option is there where A is equal to 3. So, in terms when there is a long calculation problem, first see the simplest way you can calculate this question. Okay, like this, we need not to multiply. We know 1 electron is there. Multiply by 965,400. We will get the same answer and we will get answer. So, we get the answer A directly from here. You can see by calculating that if we multiply 96500 by 2, we will get the answer 4. B is for 4 and C is for 2 and D is for 1. While solving, you will get the same answer. Just you need to multiply 96500 with 2, 3 and 4. Okay. So, in exam, try to solve it quickly. Just see which is the easiest calculation. Is there any option? Rule out the other options and you will get the answer very quickly. Don't waste time on such questions in solving each and every point in the exam time. Okay. Go ahead. Catalysts are used to increase the rate of a chemical reaction because it decreases the activation energy of the reaction. Yes, this is the only answer. If we decrease the activation energy while reaction, if we add catalyst, this is the activation energy. If the activation energy is decreased, then the rate of the chemical reaction will increase. See, catalyst is a substance which itself don't involved in the reaction but increases the rate of a reaction by decreasing this activation energy of a reaction. Okay, by decreasing the activation energy of the reaction. So, this is the right answer. We need not to move further. This is for sure the right answer, that decrease the activation energy of the reaction. Half-life of a first order reaction is 20 seconds and initial concentration of the reactant is 0.2 molar. The concentration of reactant left after 80 seconds is. This is a question from chemical kinetics. Okay. So, we need to calculate the concentration of a reactant. How will we calculate? The easiest formula is AT after time T concentration, and at the initial stage, it's half raised to power N. This N is the number of half-life. Okay. So, how will we calculate N? Since N is equal to T by T half. So, we have time after 80 seconds. So, T will be 80 and T half is 20 seconds. First T half is 20 seconds. So, if we cut this N value will come out to be 4. Just put the value of N here. 18. This we need to calculate. A naught value is given 0.2 molar. 1 by 2 raised to power 4. So on solving, you will get the answer 0.0125 molar. Okay, so this way very easily by using this formula, you can calculate the value of a concentration of a reactant after certain time. Okay, so B is the right answer. In the given graph, activation energy for the reverse reaction will be, so for the formula is delta H is equal to E activation energy of forward minus backward reaction. This is very simple calculation. See, the value of delta H is given. This is 90. For forward, it is 215 kilojoule. Minus, we need to calculate this activation energy for the backward reaction. Just minus, add, we will get the answers. EAB is 215 plus 90. So the answer will be, solve it. It is 215 minus 90. What it comes out? It comes out to be 125 Kelvin. Okay. So 125 kilojoule is the right answer. For the reaction 2N2O5, see how many questions are given from the chemical kinetics. Last two questions were also from there. This is also from the chemical kinetics. For the reaction 2N2O5, 4NO2 plus O2, initial concentration of N2O5 is 2 mole per liter. And after 300 minutes, it is reduced to 1.4 mole per liter. The rate of production of NO2. Let's solve it. First, write the rate for this reaction. How will we write? It is for reactant side, as it is a rate of disappearance, we will use this minus sign. And for this stoichiometry, we will write minus 1 by 2 dN2O5 by dt is equal to, for product side, we will use plus sign 1 by 4 dNO2 by dt is equal to dO2 by dt. He has provided the initial concentration of N2O5 and we need to calculate the rate of production of NO2. So we will consider these two terms only. So for this dNO2 by dt on rearrangement, we will get this 2 will go this side. It will comes like 4 by 2 dN2O5 by dt. So it will cancel, 2 will come here and 2 values are given here. Na? Initial concentration of N2O5 is this and after 300 minutes it is reduced to this. So it comes out to be 2 minus 1.4 minus 2 by T is given 300 minutes. So it will be like this. So on solving, you will get the answer 2.5 into 10 raised to power minus 4. So this is the right answer, 451. Please solve it at home. This is a very simple calculation. You will get the answer 2.5 into 10 raised to power minus 4. Okay. Which of the following methods of expressing concentration are unitless? See, all these are the concentration terms. Molality, mole fraction, mass percent, and molality, mole fraction, and mass percent. See, in some this question, if only you know the molality units are m, small n, then also you can solve. In all the options, there is molality. And molality units, you know, for molality we end with small m. For molarity we use capital M. For normality we use n. And they all have units. Okay. So mole fraction and mass percent are unitless. We have seen in the last questions also that mole fraction are unitless. So this is the right answer, mole fraction and mass percent. Let's move to the next question. Select the incorrect statements from the followings. Let's see. 22 books have infinite significant figures. This is true. When 22 means any number of zeros we can add to it, so it has infinite significant figures. So this is very true. A statement is right. And he is asking about the incorrect. Please focus. In question, whether they are asking correct or incorrect. It is very important, okay? In the answer of calculation, 2.5 into 1.25 has 4 significant figures. Well, this is not right. See, when we multiply these two terms, we will see because in the question here, only 2 significant figures are there. Minimum are 2 now. So, when we get the answer, we will round it off into 2 significant figures. So, 4 significant figures will not come. So, this is the wrong statement. Okay. See, 0 proceeding to first non-zero digit are significant. Is it so? No, na? See, whenever we add 0 before any digit, these are not significant. Only the 0 after the digit are significant. So, C is the wrong statement. In the answer of calculation, this has 3 significant figures. This is also true. Here, the minimum number of significant figures are 3. So, whatever the result will be, we will round it off to the 3 significant figure. So, the option A and D is correct, and the question is asking about the incorrect statement. So, the option A is right, that B and C only are incorrect statements. Okay? Given below are the atomic masses of the elements, and which of the following does not form triad? See, in such question we just see that only those elements will form triad which have the similar properties. So here, let's see, all chloride, bromide, iodide, these are from halogen, so they are similar. So this can't be the answer. See here, these two are metals, potassium and calcium, while chlorine is a non-metal. So this is the right answer. They can't come in a triad. Okay. From here also you can see potassium, calcium and chloride. They are not in the same region. Okay. They are metal and they are non-metal. So this can't form a triad. So the B is the right option. See here, lithium, sodium, potassium, these are also metals. All three are also metals. So B is the right answer in this case. Only those elements form triads which have a similar properties. Okay. The change in hybridization of the aluminium atom in the following reaction. We want to see that what will be the change of hybridization will come from AlCl3 to AlCl4 negative. Draw the structure of aluminium chloride. It is like this. So it is sp2 hybridized. And by adding one more chlorine to it, it will be, that is sp3 hybridized. Here 3 sigma bonds are there and here 4 sigma bonds are there. So it is moving from sp2 to sp3 hybridized. So A is the right option. Among the following 0.1 molar aqueous solution, which one will exhibit the lowest boiling point elevation, assuming complete ionization of the compound in solution? So we are assuming that it will completely ionize. So let's see. So here the formula is, for elevation in boiling point, delta TB is directly proportional to I kBm. Here we will see from this delta TB directly proportional to I. If means if somebody has lowest number of ionization, after ionization the lowest number of ions we will get will be the lowest boiling point. So let's see, aluminium sulfate, that is Al2SO4 3. So here the I value will come out to be 3 plus 2, 5. It will dissociate into aluminium 3 positive, 2 aluminium 3 positive and 3 SO4 2 negative. So 3 plus 2, 5 ions we will get. In case of potassium sulfate K2SO4, the value of I will be 3. That is 2K positive and SO4 2 negative, right? Sodium chloride NaCl, it will dissociate into Na positive and Cl negative. So the I value will be 2. And aluminium chloride AlCl3, it will aluminium 3 positive plus 3 Cl negative. So I value will be 4. So out of these three, sodium chloride has the lowest I value, that is it will complete ionization. It has the lowest value, so delta TB value will also be the lowest one. So lowest TB value will be for sodium chloride. This is the right option. Match list 1 with list 2 and select the correct option. Here the molecules and ions are given and we need to calculate the bond order. If we go with the general formula in which we calculate the value of bond order by half number of bonding minus anti-bonding electrons, then this will be very lengthy. But in a question we don't have that much time, so we will solve this question with the help of a trick. For this, write it down that from 8 to 20 number of electrons, that is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. The bond order will be start from 0 and end with 0. Okay, and for 14 it will be 3. Just go in this increasing order 0.5, 1, 1.5, 2, 2.5 and 3. And again decreasing order 2.5, 2, 1.5, 1.5 and 0. So now we need to just calculate the number of electrons for NO. It will be for nitrogen 7, oxygen 8. How 7 for nitrogen? Nitrogen electronic configuration is NS2NP3. Okay, so it is 1s2, 2s2, 2p3. So the number of electrons here are 7. Likewise for all the atoms. So it is NO is 7 plus 8. It is 15. Here see what is the value of 15 for bond order? It is 2.5. So match 15 by 2.5. Okay, very simple. CO it is 6 plus 8. So it will be 14. So 14 it is 3. Match this. B with 4. O2 negative 16 plus 1. So it will be 70. For 17 it is 1.5. So this is the right bond order. O2 it is 16. 16 it is 2. So this. So let's see A with 3. Yes, this is the D is the right option. A with 3. A with 3. B with 4. C with 1 and D with 2. In this way, by using this trick, you can solve this question in just 1 minute. Okay? So use this formula. Next is the electronic configuration of X and Y are given below. See the electronic configuration. It is NS2NP3, NS2NP5. Means this is a nitrogen family and this is the halogen family electronic configuration. So see, whatever exam you are going to prepare, you must know the electronic configuration of all the periodic elements. For all the periodic elements, either it is S block, P block, D block, F block, it is very important. Please do it because maximum number of questions in inorganic chemistry requires electronic configuration. Okay, it will definitely going to help you. See, so this is a nitrogen family, this is a halogen family, and he is talking about the type of bond between X and Y. See, it is X. It can be nitrogen, phosphorus, okay, nitrogen, phosphorus, arsenic, antimony, bismuth. And in this case, Y, it can be fluoro, chloro, bromo, iodo. Here in this case, nitrogen family can lose either 3 electrons and can form a stable configuration or 5 electrons from the outermost shell and form a stable configuration. So it will be either plus 3 or plus 5. So it can form either XY3 or XY5 compound. Okay, like PCl3 or PCl5. Let's see any option or like that. Yes, XY3. And which type of bond will be there? Covalent bond. What is covalent bond? It is formed by a mutual sharing of electron between the two atoms. Okay. So in this case, B is the right option. Match list 1 and 2. These are the types of redox reactions are given and we have to match these reactions with the example. So first is the combination reaction. What a combination reaction? When we add 2 or more reactants and get a single product, that is known as a combination reaction. Is any example match with this? I don't think so. But if we consider this as a combustion reaction, then this is a combustion reaction. Let's move on the next options, then we will see. Next is a decomposition reaction. Decomposition reaction is when a single reactant is decomposing into or break down into two or more products that are known as decomposition reactions. So here, this fourth and second, both are decomposing. So they both can be a decomposition reaction. So A goes with 3 in this and this. B with 2, B with 4. Both can be the possibilities. So we will first rule out A and D because A with 2 and A with 4 is not possible. These are not combination reactions. So this is not true. So these are not combination reactions. So now we need to just find out from B and C which one is the right option. Next is displacement reaction. What is displacement reaction? This A first, this is a displacement reaction. That is the displacement of an ion in a single compound. This is from chloride to Cl negative. This is the displacement of a ion or a compound in a compound. Okay. What is disproportionation reaction? This is a special type of a redox reaction in which a single reaction contains both the oxidation and reduction. Such type of reactions are known as disproportionation reaction. Say this H2O2 to H2 plus O2. This is an example of a disproportionation reaction for sure. Here the oxidation state is -2. Here it is -1 and here it is 0. So here it is -1, here it is -2 and here it is 0. So it is converting from -1 to -2 and -1 to 0. This is oxidation and this is reduction. Here it is a gaining of electron, here it is a loss of electron. So in a single reaction, both oxidation and reduction are taking place. So this is known as a disproportionation reaction. So see, D matches with 2 in this option. So this is the right option. Most appropriately, we can use this only because for combination reaction, we can't understand. This is not a combination reaction. No one is there where we can also give combustion reaction. So there's little mistake in a question paper. So you consider this as a combustion reaction and this is a combustion reaction. By considering this, assuming this, B is the right option. Okay. Let's see the last question. In the following pairs, the one in which both transition metal ions are colorless is C. Which metal ions will be colorless? Where the electronic configuration is either fully filled or zero filled. So in this case, let's see. So you must know the electronic configuration for all the transition metal ions. Let's try. Here it is vanadium, titanium, zinc, manganese, titanium, copper, scandium and zinc. All these are 3D1 series. Okay. So let's, in a short, we can write like scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Okay. And they are talking about vanadium, titanium, zinc, manganese, again titanium, copper and scandium and zinc. So this is scandium and this is zinc. So only scandium and zinc on oxidation, that this 3 positive, if we remove 3 electrons from the outermost shell, the electronic configuration comes out to be argon 3d0 and here it will be argon 3d10 for zinc 2 positive. So this is zero filled and this is fully filled. Only these two transition metals will be colorless. Apart from them, all must have some electrons in the outermost shell, so they will be a colored ions. Okay, they can transfer the electrons from the ground state to the higher excited states, and these metal ions will be colored. Only this scandium and zinc is the right option. So D is the right answer. I hope you understood all these questions. If you have any problem, you can please comment in the write down in the comment section and we will try to solve your questions and problems. Thank you.